negative 5 to 0 of g of x, that's mathematically equivalent to just doing the integral from negative 5 to 0 of f minus what? G. Cool? Alright, so this brings us to the general way that we will find area between two curves. So this is kind of like those problems that you did when you were in geometry where they gave you like a square and then they gave you a circle inside and then they asked you to find that little space that was left over, right? So you had to get like the big square area minus the area of the circle and that left you with the space, right? The same idea is happening here. You're getting the area bounded beneath the one that was higher and then you're subtracting the area beneath the one that was lower and that leaves you the area of the bounded between the two curves, right? The same type of idea. So I'm going to make it pretty general here. And instead of putting things with functions and stuff, I'm just going to say that it's always going to be the integral of the top function minus the bottom function. So you got to figure out which equation is on top, which equation is on bottom. And if I want that bounded area, I'm going to do that top function minus that bottom for whatever interval it's in that form. Because there's going to be times where this curve goes like that, and then it goes down. So like in one interval it's on top, but in another interval now that equation is where? On the bottom, so you have to separate. Okay? We'll look at examples like that. So, basic simple thing. Area between curves, don't make it hard. Okay, it's going to be the integral from a to b of the top function minus the bottom function with respect to x. These guys are x values. Okay? Easy? Now these limits right here sometimes are going to be where the two curves intersect each other. Sometimes they're not. Sometimes they're just going to give you two curves drawn and it's like they cut it and they said, okay, find the area from here to here. And they're not actually connected to each other. Okay? So it all depends on what restrictions they give you in the problem. Some of them might say, find the area bounded between this curve and this curve. So they didn't tell me a specific interval. So that means that these two curves probably what? Intersect each other, and I need to find those points, and then I need to find the bounded space. Those will be my limits. Do you understand? Sometimes they'll say, find the bounded space between this curve and this x and this x. Right? So now they're giving you everything that you need. Right? So in that case, it might not be that they're intersecting each other. Okay? So it depends on the particular problem. Alright, now, sometimes we have graphs that we don't know which one's on top and which one's on the bottom. So like if it looks like this, I don't know which one's on top and which one's on bottom. But I know which one's on the what? Right, and which one's on the left. So for this problem, you have to change your mentality. Okay, this one we're not going to be working in respect to x, we're not going to be working with respect to what? To y. Okay, so whenever you don't know top and bottom, the area is going to be the integral. Now we're working with y values from c to d. So these are going to be y values now. And instead of doing top minus bottom, here you're going to do the right curve minus the left curve, and it's going to be dy, not d what? X. Okay? So you got to be careful here, okay? So you're going to have to make your functions, okay? They're going to have to be x equals instead of being what? Y equals, okay? So you're going to probably be given functions that are y equals, but then you draw them and you're going to see that, okay, I don't know which one's on top, which one's on the bottom, but I know that this one's on the right and this one's on the left. So if that's the case, I got to make both of those functions x equals, remembering which one was on the right and which one was on the left, and then subtract them and work with that integral. So that's the only thing that changes, is that you need to put them in terms of y, and then work with it like that. Okay? And your limits are not x values anymore, they're going to be y values. Do you see these two don't intersect, right? So on this one, they probably give you these restrictions. So they say the area bounded by this curve, y equals c, and y equals d. So they give you like all the information for you to draw, and you would find that bounded space. Got it? Easy? Alright, let's try an example and see what we got. Might be only able to do one or two. So find the area of the shaded region R that is bounded by y equals sine of pi x and y equals x to the third minus 4x. So we gotta start off by identifying which function is which one. Which one do you think is sine of pi x? The one on the top? Okay. So this guy right here is sine of pi x. So we know who's on top. Is he on top all the time? No?
Maybe.
What do I mean when I say on top?
Well, the other function.
On top of the other one, okay? Not on top of the x-axis, on top of the other function. So is he always on top of the other one? Yes. So I'm never gonna have to switch an interval. I'm never gonna have to do right minus left. That's something that you need to remember. Okay? Good? Alright, which one's on the bottom? X cubed minus 4x. Yes? Alright, so let's check this bad boy out. Alright, if I wanted to find the area, we said it had to be the integral from a to b of top minus bottom with respect to x. So which function is the one on the top? So this is going to be sine of pi x minus what? Put parentheses, x cubed minus 4x dx. Do you see how easy it was going to be to just put minus x to the third minus 4x? Okay, you got to be careful. Yes? Alright. So then, the limits, what would be my limits? 0 to 2. How do I know it's 0 to 2? Because that's where they're intersecting, right? What would I do if they didn't give me a graph? How would I find those intersections? What would I have to do to find the intersection points if I didn't have a graph? Very good. Set them equal to each other and solve for x. Okay? What if they didn't give me a graph but I have a calculator? It's on the calculator part. Could I find where they intersect on the calculator? Could I draw the graph and then just find the bounded area? Yes, the calculator can do all that for you. So that's why I'm saying it's more than likely not going to be on that section. Okay? Cool? So let's do it. Okay? This is really the integral from 0 to 2 of sine pi x minus x to the third plus 4x dx. And let's integrate each part. It's going to be the integral of sine of pi x. What's the integral of sine of u? Negative cosine? Okay, so it would be negative cosine pi x. What are we missing in the front though? Not pi. 1 over pi. Okay? Minus 1/4 x to the fourth plus 2x evaluated from 0 to 2? 2x squared, yes, you're right. I divided by 2, but I didn't put the 2x. We okay?
Yeah. Mr. Science, why is it 1 over 5?
Why is it 1 over pi? Alright, so we're looking for that license to integrate, right? So what would the license to integrate be? Pi, because that's the derivative of that. I don't have a pi here, right? So if I add a pi there, then what would I have to add on the outside? 1 over pi. Yes? Are we okay? I didn't want to have to do this. U equals pi x. Du equals pi dx. So on and so forth. Cool? Trying to pick up the pattern since we've been working with them for a while. Alright, so let's do it. Plug in the 2. Negative 1 over pi cosine of 2 pi minus 1/4 2 to the 4th plus 2 times 2 to the 2nd, all of that minus negative 1 over pi cosine of 0, and then I think the other two are going to be 0, right? Okay? Yeah? Alright, so what's cosine of 2 pi? 1 times negative 1 over pi, that's negative 1 over pi, right? 2 to the fourth, 16. 16 divided by 4, negative 4. 2 to the second, 4 times 2, so plus 8. Cosine of 0, 1 times negative 1 over pi is negative 1 over pi times negative becomes plus 1 over pi, and everything else is 0. So these guys seem to cancel out. Negative 4 plus 8 is 4. And that would be the area. Cool? You want to see if that's the right answer on the calculator? Alright, so let's see. Go to a graph page. You could do it on a calculator page and type in the whole integral, but I wanted you to do it on the graph page so you can see how cool it is. Right? So type in both equations. Doesn't matter the order. Sine of pi x, enter. Tab. We got x to the third, right? Move to the side, minus 4x. Cool? We could adjust our window if we wanted to. Do you want to adjust it? Okay, let's adjust it. So menu 4, 1. So it seems to be going from 0 to 2, right? And it's going by 1s on the x's. The y's are going from negative 3 to 1. And that's also going by 1s. Invalid values, what? Oh, why did I put 0? Cool? Now it looks like the one I have there. Now, all I have to do is go to menu, go to number 6, and what do you think I'm going to pick? Bounded area. Okay, and then you tell me the interval that you want. So we want it from where? From 0, so put 0, enter, and then press what? 2, enter, so there's no guessing. What do we get? 4, it's kind of hard to see, it's right here, right next to this 1. Okay, but it's right there. Cool? Notice that it was positive even though I have more space where? Below the graph than above it, right? Because here they're not treating it as negative space, they're just treating it all being what? Positive, because they're talking about area. You understand? Yes? Pretty cool? Alright, so know that the calculator has that ability if it does come out on the calculator part, but I highly doubt it. Okay? Try another one? Yes? Let's see how far we can get on this one, and then we'll just stop there. You got 3.9999?
Yeah.
That's weird.
Yeah, I also got that.
Well, it's pretty close to 4, right? Alright, so let's check this one. Picture to the right is the graph of f of x. That's probably this curvy one, right? And a line L, which is tangent to f at the point 0, 3. Find the area of only region R. How do you think I'm going to find that area? And for this one, I'll allow you to use your calculator. Do I get all of it and then subtract it? I don't know, what do you think? I just want this space. Is there another curve that it's bounded by? Or are we just looking for the area underneath that curve? And the x-axis? It's just the area underneath that curve and the x-axis, right? Yeah. So what should it be? What should be my limits? Do I know them? I know it's from whatever this is to what?
0.
To 0. Oh man, how am I going to find that one? Plug it in, right? Okay, so go to a graph page. That's one of the things you need to be able to do on the AP test. Okay? So we're going to type in this equation, right? X to the third over 3 minus x squared over 3. Oh, just kidding, I'll fix it. Minus x over 2 plus 3 cosine of x Let me change that one to a 4 because I missed it. Cool? Alright, so we need to find those intercepts, right? How do you want to do it? You want to do it one at a time? You want to do all of them? One at a time? What did you say? Menu? 6? 1? Alright, so let's find this first one. Get on the left, move it to the right. And what do we end up with? Write as many decimals as you can. Negative 1.37312. Good. Alright. So what are going to be my limits for this interval? Negative 1.37312 to 0. And what function are we going to integrate? F of x dx. This is on the calculator, okay, section? So you are allowed to use the calculator. So let's try it. What are we going to end up with there? Can we use this calculator to give it to us right now?